How is research on lifespan development conducted? First, let's discuss different methods for collecting data. One method is systematic observation. This can take place either in a controlled laboratory setting or in a real-world setting. They each have their pros and cons. On the one hand, a laboratory setting allows the researcher to control for potential complicating factors that could influence behavior. On the other hand, simply knowing that we're being observed can often cause people to change their behavior. Sometimes the most straightforward way to find out about someone is to just ask them. With surveys and interviews, a standard set of questions is used to obtain people's self-reported attitudes or beliefs. It's a good way to get a lot of information from a lot of people in a short period of time. But one drawback is that individuals may not tell the truth, especially if it's about an uncomfortable or embarrassing topic. Surveys and interviews can come in many forms, such as standardized tests in which allow you to compare performance with others, case studies which give you in-depth information about a single individual, or physiological measurements such as hormone changes, neuroimaging, or gene assessment. In addition to knowing how you're measuring your data, you need to decide what your research design is going to be. This will largely depend on what kind of question you want to answer. If you just want to observe and record behavior without trying to predict or explain it, then that would be descriptive research. But maybe you are interested in learning more about the relationship between two events or characteristics. If the occurrence of one thing tends to follow the occurrence of another thing, then there is said to be a correlation or a relationship. The strength of this relationship can fall anywhere from a positive one to a negative one. Positive one means that as one event or characteristic increases, it perfectly predicts the increase of another event or characteristic. A negative one means that as one event or characteristic increases, it perfectly predicts a decrease in another event or characteristic. A correlation coefficient of 0 means there's no relationship. So closer to 1 in either direction is a stronger relationship, and the plus or minus just tells you which direction it's going, whether an increase in one is associated with an increase in another, or whether an increase in one is associated with a decrease in another. Now, if you learn nothing else in this course, please learn this. Correlation does not equal causation. Just because one thing predicts another does not necessarily mean that one thing caused the other. For example, it might be observed that as permissive parenting increases, children's self-control decreases. There are many possible explanations for this observed correlation. Maybe permissive parenting causes children to develop poor self-control. Or maybe parents of children who lack self-control cope with it through permissive parenting. Or maybe some third factor is causing both. So maybe a genetic tendency or the stresses of poverty are causing both the permissive parenting style and the children's lack of self-control. Correlation is not causation. Correlation is not causation. And I'll say it again, correlation is not causation. So what do you do if you want to find out whether or not one thing really does cause another? Well, then you have to use an experimental research design. You have to follow very carefully regulated procedures in order to manipulate only the factors that you're interested in and hold all other potential causal factors constant. My son once did this in an experiment for a school project where he tested different stain removers. The factor he was interested in manipulating was the type of stain remover. He washed stained swatches of fabric using different brands of stain remover. In the meantime, he held as many other factors constant as possible. Each swatch of fabric was the same type of fabric, the same color of fabric, stained with the same amount of the same substance, soaked in the stain remover for the same amount of time, washed at the same temperature, on the same settings, in the same washing machine. The factor he was interested in measuring afterwards was the amount of stain left over. That was his dependent variable. When you're using human subjects, you need to have an experimental group and a control group. The experimental group is the group whose experience is manipulated by the researcher, and the control group is just a comparison group that doesn't receive anything special or unusual. It's just business as usual for them. So for example, you might randomly assign kids who are learning how to read to one of two groups. One group, the experimental group, might receive a new form of reading instruction. The other group, the control group, would just receive the type of reading instruction that they would normally receive. Then you can compare the two groups to see if the new type of reading instruction resulted in better, similar, or worse reading progress than the usual instruction. So imagine that you have decided to conduct an experimental study of the effects of aerobic exercise by pregnant women on their newborns' breathing and sleeping patterns. You would randomly assign pregnant women to experimental and control groups. In the experimental group, women would engage in aerobic exercise over a specified number of sessions and weeks. The control group would not. Then when the infants are born, you would assess their breathing and sleeping patterns. If the breathing and sleeping patterns of newborns whose mothers were in the experimental group are more positive than those of the control group, you would conclude that aerobic exercise caused the positive effects. Another thing to consider when doing research is the time span of research. With a cross-sectional approach, you can compare individuals of different ages at the same time. So, for example, you might compare a group of 20-year-olds to a group of 50-year-olds. This is a faster way to get data, but you can't be sure that any differences you find between the groups are due to aging or due to historical influences. A way to get around that is by using a longitudinal approach. Here, you study the same individuals over time. It gives you much better information about stability and change over the lifespan. But of course, it takes a long time. After all, you might have to follow those 20-year-olds for the next 30 years until they are 50 years old. People move, people die, people drop out of the study, or simply go missing. It's hard to pull off. A group of people who are born at a similar point in history and share similar experiences as a result is called a cohort. Baby boomers, Gen X, and millennials are examples of cohorts. If you're using a cross-sectional approach, you have to be careful not to confuse age changes with cohort effects. Is this group of 30-year-olds reluctant to spend money because 30-year-olds are more cautious about spending? Or are they reluctant to spend money because this cohort experienced a major economic recession just as they were graduating from high school and college? There's a lot to consider and a lot to untangle when doing developmental research. So to review, today we discussed the distinctive features of the lifespan perspective on development. We identified the most important processes, periods, and issues in development. We described the main theories of human development, and we explained how research on lifespan development is conducted. Throughout the rest of this course, we will be exploring these processes, periods, issues, and theories more in depth in order to get a well-rounded look at why we are the way that we are.